Okay, we are discussing about what is that? Divide and conquer. Yes or no? Divide, divide and conquer. So this is the topic we are discussing. So what is this divide and conquer is nothing but very simple. Okay. So think like that we have a big problem, something like P. Okay, this is a big problem. That problem will be divided into number of parts, something like P1. Okay, again something like P2. Again something like P3. Again something like PK. So we have a big problem P. So this is the big problem. I will say this is a big problem. Big problem. So what I did with this particular problem, big problem, I divided into number of parts, nothing but what is that? So parts are, we will call it as sub problems. This is a sub problem. Okay, so this is a sub problem. This is also sub problem. This is also sub problem. This is also sub problem. Okay, and finally, how we are going to divide this one? Using recursion. Using recursion. Using recursion. Using recursion, I will going to divide the big problem into number of parts, nothing but small parts. That is called it as sub problems. Okay, so we will going to call recursively until we get. So how long you will going to call this one? This we have a big problems here. We have a big problem. To divide all this big problem into sub problems, what I will going to do? I will going to use the technique that is called it as recursive technique. Recursive technique. How long you will going to call this recursive technique? So we will going to call this recursive technique until I get the solution for sub problem. Here, until I get the solution for this sub problem. So until that we will going to call this one. If I got the solution for this sub problem, if I got the solution for this sub problem, what I will do? Finally, I will going to combine. I will going to combine all subproblems together. Okay, all subproblems will be combined together. Again, you will going to get a solution for this particular problem. All the problems, whatever the subproblems is there, for every subproblem you are getting a solution. All those solutions will be combined together. You will going to get a problem for, you will going to get a solution for this particular big problem. So finally you got the solution for big problem. So basically this one we will call it as divide and conquer. Already explained. Okay. Basically another way, I can say another way. What do you mean by DAC? Divide and conquer and combine. What do you mean by divide and conquer is nothing but it is a recursive algorithm. Okay. It is a recursive algorithm. So why I'm calling recursive algorithm? When you're doing division, what we are going to do? We are going to use the recursive until where? Until I get the solution for that particular sub problem. So after getting the problem for every sub problem, what I will going to do? I will going to combine together. Finally, we will going to get the solution for the big problem. That is what exactly it's called about divide and conquer. Here, let's go to the next slide. Please observe here. Everybody, please observe. Okay. Let's take, I'm talking about some general method here. Let's take one array. Everybody observe here, please. Let's take one array like this. Okay. Let's take an array like this. Okay. This is an array. Okay. Here, P is an initial index. Q is end index. You take that. P is the initial index here. Q is a last index. Okay. This is in a small array. So what I will do, I will going to write a algorithm for this. Just observe here. I will going to write a algorithm. What is this? Basically, this is an array. Basically, I wanted to find out first whether this array is a big or small. I have to find it. Yes or not? Whether I have to find this one. The problem, whatever the array I have taken, this array is big or not or small. We have to find it. To find this, whether the array is big or small, what we need? We need a function. Yes or not? We need a function. That is very, very, very important. So that is the reason why if I do all those functions, we need a function. Yes or not? If I want to identify whether the array is given array is big or small, we have to identify for that. If I wanted to identify this one, we need a function. That's why what I will going to do, please observe here. I have an array. Okay, that is a divide and conquer function I am taking. I have an array. Array name I will going to call it as A. Please understand. Array name I will going to call it as A here. Index starts from where? P. Index ends here where? Q. So that is the reason why A, P comma Q. So this function I have taken. Why I have taken this function? A is an array. Please understand. A is an array. P is the initial index. Again, Q is the last index. Nothing but n minus 1. Okay. Now this is the function I created. Inside the function, what I have to find out first? Please understand what I have to find out first. I have to find out the given array is big or small. I have to find it. Understanding everyone? The given array is big or small. I have to find it. That is the reason why what I will going to do. I will going to create one condition, that is if small array A, index P, starting index and ending index is Q. And you ask me, sir, why you have written small here? Small is a function, indicates the given array is small or big, it will going to say. This is a function. What is the use of function? It will going to do some task, right? It will going to perform one particular task. That is the reason why I have taken one function that name is small. Small will going to check the array from initial index to last index. Initial index to last index, it says that very clearly the given array is big or small. It will going to say that is the reason I have taken. Suppose, think like that. If the given array, think like that. If the given array is small, if this condition is true, if I told you, if the small A, array A, P is the initial index, Q is the final index, nothing but last index. If this index and array, okay, says that very clearly, the given array is small is nothing but what it will going to say? It will going to say return. Okay, solution. Don't worry right now, don't worry. Solution is also function here. I will tell you what is this exactly. Okay, don't worry right now, don't worry right now. Solution is also a function, don't worry. Okay, so it will go to return nothing but what exactly I'm talking about. If this given array is small array, means what it will go to do? You will go to return something. That is what exactly what I'm returning is nothing but I'm returning the solution function saying that this is a small array. Okay, this is a small array. So what I'm saying, solution A, P comma Q, nothing but array A, index P to Q. I am returning. This one is over. Everybody understood? Now, suppose think like that. The given array, this one, see here, the given array. Okay, the given array. Suppose if it is not small, think like that. This is the array. I told you, right? I given one array. If this array is not small, then what we have to do? We have to go to the else part. You know already why I'm writing else part, because I taken one array. Just I wanted to say whether the array is big or small. I wanted to say very clearly whether the given array is big or small. That's why I created one function saying that divide and conquer array A, index P, index start, again Q is the end. Okay, index starts from P, again index ends at the last element. This is Q. This is the first element. So after that function, what we're going to do, inside the function, we're going to write the statements or not. So that is what exactly I'm doing. If I want to identify the given array is small, means I need a function or not. Exactly, I need a function. That is the reason why I created one condition. If the small function, okay, checks whether the given array A is starting element P and ending element Q. Okay, after checking, nothing but it will going to do some recursion. After checking, it will going to return, okay, the given array is small. If this is true, it will going to return this. You know already. If it is true, if this condition is one, nothing but what? One is nothing but true. If this condition is true, it will going to return this. Suppose think like that. If it is zero, nothing but false, where it will go? It will go to the else part. Again, see, I have to, everybody please observe this one. Please everybody observe here. What I'm saying, I am going to the else part. See, if this is array is not small now, okay, if you are going to the else part is nothing but it says that very clearly your array is not small. Hence, I wanted to divide this array like this. Okay, I wanted to divide this array into two parts. Okay, if I want to divide means I need a function or not. So that is the reason why what I will going to do, I will going to create one function. That function is m is equal to, okay, why I am taking m, nothing but middle element, middle, I am talking about middle. So middle is equal to divide a comma p comma q. Which array you are dividing? The array first index to last index you will going to add, divide by 2, you will going to get it. That array you will going to get it. That is the reason why I have taken m here. Okay, m is nothing but mid. Okay, now what do you mean by m? M is nothing but mid here. I think everybody okay. That is fine. If you are taking this function, I will going to divide this array into two parts. One is what? I will going to take one part as a B1 part. I divided. This is we got M. Again, one part will be B2 part. Okay, now I have taken an array. So this array is not a small array. So I divided now because using this function. So I got B1 and B2. I will going to tell you. When I divide this one, I will going to get some values. Yes or not? I will going to get some values. That is B1 is equal to recursion. See here, this is what I am talking about, recursion. If I want to divide means what I need to do? I have to do the recursion. That is the reason why divide and conquer array A. Okay. Phi, nothing but initial index and middle. Nothing but what? B1, nothing but from year to year. See here, from P to M, middle. P to M, that is called it as middle. You got it? Everybody got it? P to M, middle. This is B1. We divided. Yes or not? We divided this one. Again, as it is like that, B2, that is equal to divide and conquer function. Because this function, you see, this function, both are same. It indicates very clearly it is a recursion. Function call by itself. Yes or not? This is a function. Calling here inside, nothing but what? Self-calling is happening. Nothing but what? Recursion. Okay. Now see everybody, array. Okay, what is that? See, m is there. Until here, m is there. M plus 1. Please understand here. M plus 1. M plus 1. M plus 1. Mid plus 1. Comma. What is that? Q. We got B1 as well as B2. Nothing but two parts are divided here. This array divided into two parts like this. One part. Again, this is one part. Just I wrote a small code here. That's it. After dividing this one, for example, you take this like this. In this, some elements are there. Okay, I wanted to identify which is greater, which is smaller. Okay, nothing but bigger and smaller, maximum and minimum. Think like that. In this, 75 is there. Here, 150 is there. Here, think like that, 34 is there. You check in this, which is maximum, 150 is minimum. If 75 is minimum. In this, check it. 34 is there. Which is maximum? 34 is maximum. Again, minimum is what? 34. You take it like that. Okay. Now, when you combine this one, okay, we will going to combine this like this. Okay, for maximum, we will going to check it. So compare this 75 and 34, which is maximum. 75 is maximum here. Again, 150 to 34, we will going to compare. Nothing but maximum will be replaced to 150. Again, here. Again, we will going to check with the minimum. 75 or 34 minimum. Which is the minimum? 34 is the minimum. Like that, we can able to get it. That is the one reason we are dividing this array into two parts. Okay, that is the one reason we are dividing array into two parts. Otherwise, why should we have to divide here? Yes or not? So now, see, after dividing this one, this is basically completely recursion. Please understand here, this is completely recursion is doing for division. Until where you will going to divide? Until I get the answer for that sub problem. Yes or not? I will going to do the recursion. Until I get the answer for sub problem, until that I will going to divide. That is what exactly this is. That is what self-calling recursion is happening here. DAC, nothing but divide and conquer, A comma P comma M. Okay, nothing but what? Here recursion, again division will going to happen. That is what same thing. Okay, it will come here. It will going to check whether it is small or not. Again, it will going to check. Okay, if it is small, return the solution. Or otherwise, divide again. This will be divided again. Again, this will be divided like that. Understood everyone? Getting? I think you people are getting. You people are very clever people. I think you people are getting. So this is divided into two parts here. Yes or no? Now, after division, okay, after division, think like that. B1 you got the answer. B2 you got the answer. Finally, what we have to do? Finally, what we have to do? We have to combine or not? So that is the reason why. See here, everybody. C is equal to. Okay, C is equal to. We have to use the function here. Combine. Combine. Who will going to combine now? B1 comma B2. Yes or not? Very simple. Very easily I explained. You don't know how much easily I explained. You don't know, but I am explained very easily. Yes or not? Again, finally, what it will going to return after combining? If you combine these two results, finally, you will going to get the result answer. What is that? That is C. Maybe minimum and maximum. Okay, minimum and maximum. Fine. So this is a small snippet. You can see this is a small snippet we have created here. Very, very small snippet. Nothing but small piece of code. We have created a small piece of code here. Clear everyone? Everybody understood now? So why we have to do the divide and conquer? The reason is very simple. If I do the divide and conquer and if you use the recursion, easily we can able to identify the answer. So that is the reason why we are doing this one. Again, see here in this, please observe everybody. How many functions are there here? There are so many functions are there. Small function. Yes or not? You see, small function is there here. For this also you have to write code. Understanding everyone? Small function is there. Nothing but think like that. Small function. For this also you have to write a code. Again, one more is there. What is that? Solution. One more is there. Solution. For this also you have to write a code here. Okay. Again, see here. One more is there. Divide. Function. For this also you have to write a code. Again, one more is there. What is that? Combine. This is also function. For this also you have to write the code. Nothing but in this particular program or in this particular algorithm, okay, how many functions are there? 1, 2, 3, 4 functions are there totally. Totally 4 functions are there. For this, we are unable to write the code. But even though, see here, we got this one. Everybody, we got it. Small means what is the code we have to write, but we don't know exactly how we have to write a code for this one small. But we know that Very clearly we know that if we divide this array, please understand, if we divide this array, we will going to convert into two parts, b1 and b2. Okay, again we will going to divide this b1 into number of parts, again b2 will be divided into number of parts, until where? Until I will get a sub problem solution. So we know that very clearly, if that we get a sub problem, if we got the solution for that, it is a small, it will going to return the answer. For solution also we don't know what to write. Yes or not? Solution also we don't know what to write. For divide also we don't know what to write here. Yes or not? For combine also we don't know what exactly we have to write. So that is the reason why we will call this algorithm. See here, this is an algorithm. It's not a program. Please understand here. This is an algorithm. This is an algorithm. That's why we are writing this one. What is that? Combine, return, all those things. I'm not writing any code here. So what is this algorithm exactly? It is a abstract algorithm, divide and conquer abstract algorithm. Abstract algorithm. So what is this abstract algorithm is nothing but it is a template. If you are want to do any kind of divide and conquer, observe here, if you want to do any kind of divide and conquer, you have to follow like this. You have to follow this. That is the reason why we will call this one as a standard template. Okay, we will call this one as a template. Why? Because see, take an array, divide into two parts and find out whether the divided part is small or not. If it is a small, return the solution. Solution for that, you have to write a code. Again, if it is not small, think like that. If it is not small, if it is a big array, divide into two parts. Okay. So what we'll going to get it? Still it is not a small one. Again, go to the else part. Again, call that one divide. Okay. Again, use the function that is called it as divide function. Okay. Again, divide function. What we're going to do? We will going to do the recursion. Again, we will going to divide into number of parts. Okay, like that we have to do. So this is the procedure. This is a standard template you have to follow. Okay, check whether the array is small or not. If it is not small, so go to the else part, divide that array into again two parts. Okay, still it is not small, again divide it into two parts. Still it is not small, again divide into two parts, like that. So we have to divide the array into two parts or many parts or sub problems. Okay, until you get the answer. What is that answer? Sub problem answer. Okay, until you get the answer. After getting an answer for that particular sub problem, what you will going to do? You will going to combine. You will going to combine. I will show you, don't worry. But please understand, this is the standard procedure for divide and conquer. This is a general method. Understanding everyone? This is the general method and this is the standard procedure. Okay, so after that I will going to combine. Again, I will go to return the value that is C. So like this, you have to understand. Okay, but you can able to see for this one, we cannot able to write the code. Why? Because the reason is it is a standard template. They have given you one template. In the template, you have to fill it. What I have to write here? For small, what is the code I have to write here? What is the solution code? What I have to write here? For divide, what do we have to write here? For combine, what we have to write here? Even though in companies also, if you go to the companies and all, please see here. If you go to the companies and all, they will going to provide a template. Okay, you have to fix the template. So what are the things we have to fill it? Okay, where we have to lagging here? Everything from your side you have to fill it. That is why, that is the reason why they will going to provide a template. Okay, like that. When it comes to divide and conquer, it is just a template. You have to understand what kind of code I have to write it to get the answer for that particular sub problem when you do the division in when you take a problem. You're going to take a problem. That problem is very big problem. I will going to divide that problem into number of parts so that I can be able to get its sub problems. Okay, using that sub problems when we solved using recursive, because we are doing division and conquer using recursive, we will going to solve the sub problem. Finally, what we're going to do, we will going to combine those things. Okay, so then only we will going to get the answer. That is the reason why please follow the standard method. Okay, please follow the standard method. Okay, now you can able to see here this complete this one. Divide and conquer. A is nothing but array. P is the first index. Q is the last index. What is this exactly? It is exactly is nothing but it is a size of the array. Yes or not? Size of the array or not? I have taken array. That is the size of the array. That is what exactly I am talking about here. Okay. Please be careful when you are writing anything comes to the divide and conquer. Please observe whether the given array is big or not. You have to check it. After that, you have to divide it. Wherever you go, please, wherever you go, you will going to see the divide and conquer. That is the reason why I am telling you. Now, what I will going to do? I think everybody understood that one. Okay. Now I will going to show you. Please, everybody observe here. Just I will going to show you for that how to find the time complexity for this particular algorithm. Okay, so what is that algorithm is, you can able to see, sorry, what is that algorithm is abstract algorithm. This is a abstract algorithm, divide and conquer abstract algorithm. Abstract algorithm is nothing but it is completely filled. Yes or not? No, it's not going to give you clear picture, but it's some kind of format or some kind of template. So that is the reason why we will call this one as an abstract algorithm. Now what I will going to do, we will going to find a time complexity for this particular abstract algorithm. Sir, how to do this one? Okay, how to do this one? Very simple. I will going to show you. See here, everybody observe here. Please, everybody observe here. So we are giving inputs here. Yes or not? A is an array. P is an index, first index. Q is a last index. What is this? Nothing but exactly. It is a function. Yes or not? DAC is a function. Nothing but divide and conquer is a function. Taking inputs or not? Yes or not? Taking inputs or not? A is an array. First index, last inputs or not? This is the input or not? So that is the reason why I will going to say T of n. It's a function. T of n. Okay, it's a function. Again, you can able to see if, suppose think like that, if small, if this is true, what happens? It will going to execute how many times? Only one time. Yes or not? If you want to execute this one, how many times? What I'm doing exactly now, right now, please understand what I'm doing exactly right now means time complexity. For this algorithm, I am finding time complexity. Please observe everybody. For this particular algorithm, I am finding time complexity. Time complexity finding. I'm doing time complexity finding. How to find the time complexity? I already told you this is a function. That's why I taken T of n. Nothing but n number of inputs I am taking here. Clear? After that, here. If this function, small function is true, what happens? How many times it will going to execute? It will going to execute only one time. Yes or not? That is the reason why I will going to say we go of one, because constant time. Correct? It will going to execute only one time. Yes or not? It will going to scan it. Okay, if it is a small, okay, it will going to return. That's it. Further, any loops is there? No loops. Any loops is there? No loops. That is the reason why big O of one. Okay, again come back here. Again return solution. Here also. So what it will going to do? If it is a small, what it will going to do? It will be true. Yes or not? One, it will become one. Then it is a true return. What it will going to return? It will going to return the solution. Here also same thing. Any loop is there? Nothing. No loops, nothing. That is the reason why here also big O of one. Constant. Constant. Yes or not? Everybody clear? Okay. Now, if you are clear, if you are clear, now see everybody, observe here. So till now it's over. Again, see here, what we are doing here exactly. If these things are false, where it will go? It will go to the else part or not? It will go to the else part or not? It will come to the else part. Again, here it will going to see, okay, the array is very big. Okay, the array is very big. So what we have to do? Okay, what we have to do? So nothing but this is divide is a function. Everybody observe here, divide is a function. Okay, we have an input A. Again, index array, first index, again, last index element we have here. So what we have to do? We have to divide that particular array into two parts. Yes or not? N number of elements are there. So that will be divided into two parts. So that is the reason why it's a function or not. Basically, it's a function or not. So that is the reason why what I will going to do, I will going to write f of 1. Okay, f of 1 for n inputs function. f of 1 function. Okay. Now you see. So this is a function. This is a function. What I will going to do? This complete array I am dividing into two parts. Nothing but what happens? This is a complete array. How many elements are there? 2 to the power, or you can write like this, 2 to the power of n elements. Please observe here. How many elements? 2 to the power of n elements. Okay. Now what I will going to do? I will going to divide this function into two parts. What happens? Nothing but n by 2, number of elements divided by 2. Yes or not? Here also number of elements divided by 2. Nothing but what exactly? T of n by 2. Yes or not? T of n by 2 here also. Correct? Everybody understood why I'm writing n by 2? Because it's a big array. Everybody observe here. It's a big array. I divide into two parts. Nothing but what happens? Completely n is nothing but what now? N by 2, n by 2. Over. That's why I written T of n by 2, T of n by 2. Okay, na? Now, so this is the function. What is the function? F of n function I am using for what? Dividing f of 1 function. Why I am using this f of 1 function? To divide this particular array. That is the reason why I have taken this function f of 1. Okay. Again, now here we have one more function, combine function. What is that? So this function helps when you do this division and when you do the recursion here. See here, I am doing the recursion call here, recursive call here. Yes or not? Recursion is happening, recursive call is happening here. So we will going to get the solution over here. After getting the solution, what we have to do? We have to combine or not? We have to combine or not? That is the reason why we need a function or not. So that is the reason why we have created one function here, that is called it as combine function. This one I will going to call it as f2 of n. Okay, this function I will going to call it as f2 of n. Understood everybody? Everybody understood? After understanding this one very clearly, see this, everybody observe here, see this. Now let's take a function, that is what? Array and first index and last index. Let's take a function t of n, that is equal to, here see here, if n is small, yes or not? If n value is small, nothing but what? Array size is small. What it will going to return? It will going to return index. It will going to return the constant or not. So that is the reason why big O of 1. You know why? Because the reason is here. If the index, if this returning small means what it will going to return? It will going to return big O of 1 constant. If it is small, how many times it will going to execute? Only one time. That's why big O of 1. If not, please go. If not, here. If not, else part. I'm talking about else part. F of 1 function n, nothing but f of 1. What for f of 1 here? Please observe here. What for f of 1? F of 1 is nothing but for divide. What I am doing? Divide I am doing. Plus. Okay. If I do the division, please observe here. If I do the division, what happens? You will going to get the t of n by 2 plus t of n by 2. Yes or not? Again, after doing the division, one more important thing. What is that? F of 2n. Why? Because this is combined function. This is for combined function. This is for division function. When I do the division, you are getting another two functions here. What is that? T of n by 2, T of n by 2. Again, it will be a recursive call here. Yes or no? It will be a recursive call. When you will going to do this one? Everybody observe here. When you will going to do this completely? When you will going to do this? When means if n value, see here, if n is big. If n is big, correct? Huh? If n is big, I will do this. Otherwise, why should I do? Correct or not? Okay. Now, finally, form this equation. What is that equation exactly? Very simple. I will going to write T of n, that is equal to T of n by 2, T of n by 2. What you will going to do? 2T of n by 2, 2T of n by 2. Correct. Now, finally, this is function. Both are function or not? F of n, again f of 2 n, both are functions. So what it will do? Basically, it will going to divide. Again, what it will do? It will going to combine. Okay, then both the functions I will going to take function as a f of n. Now I did something for you people in previous classes. What is that? This is the reason why we will going to use the master theorem. Understood now? This is the reason. This is the reason we will going to use the master theorem. Now you got the A. Two sub problems are there. Correct or not? Two sub problems are there in your particular problem. Okay. This is size of the sub problem n by 2. Size of the sub problem. Understand now? So this is how you will going to form the equation. This is how you will going to form the equation. Okay. So I will going to write it for you people. See here, two sub problems. Okay, two sub problems. This is already explained, but it's okay. Size of the size of size of two sub problems. Clear, guys? Everybody clear? See, from where to where we came. Understand? From where we started and where we are coming here. Now it is very easy to find the time complexity or not. So that's why you have to understand when it comes to divide and conquer, easily you can able to form such kind of equations and you can able to create a master theorem. That is the reason why they have created a master theorem. Okay. For especially for divide and conquer, they have created a master theorem. Using this one, you can able to find easily time complexity. It's very easy. Okay. So basically we know that if I convert this one into general method, what is the general method you will going to get it? That is equal to a of t, yes or not? A of t, okay, n by b. Already we know this one, n by b plus f of n. So this is the general. So finally, I wanted to say you people, master theorem. Please understand.